On the next two slides, you're given a table of input values, x's, and output values, y's, and you're asked to determine if this is a linear relationship or not. And the way you're going to do that is there are a couple different ways. You can use a graph, and you should also know how to do rise over run or slope calculations. So I'm asking you to answer both of these prompts. Show using a graph, and also show how you could know that using rise over run or slope calculations. So let's do it. So when I'm going to do this first, I'm going to show how I know using rise over run calculations. So what I'm going to do first is I'm going to look at the y's because I want to know the change in y, and then I want to put that over the change in x. So let me look here first. And I see that from -3 to -1 is a change of 2. I'm adding 2. And then I also see that from -1 to -2, that's a change of -1. So, at this point, I'm wondering, it doesn't look linear to me because these numbers are different, but let me continue before I decide. So if I look at my change in x's, from 3 to 9, that's a difference of 6. And then from 9 to 6, that's a difference of -3. It's going down by 3. So, this is interesting. So now I can't make a definitive answer yet, maybe, but let's look. So remember that slope is rise over run, and that's the change in y over the change in x, or vertical change over horizontal change. So let's do a little bit more calculation to make sure we make the right decision. So my change in y here is 2, and my change in x across from it here is 6. And I know that both of those numbers can be divided by 2, leaving me with 1 over 3. So the slope between these points is 1 over 3. So now let's look at the slope between these points. So my change in y was -1, and my change in x is -3. And I see that if I divide each one of these, the numerator and the denominator, by -1, I'm going to get 1/3. I could also think about it this way. I know that a negative divided by a negative is a positive, so that those two negatives sort of disappear. So look, we have a slope of 1/3 and a slope of 1/3, so yes, this is a linear relationship. So I just showed that using slope calculations and using rise over run. Another thing that I can do is I can use Desmos to show using a graph. So to use Desmos, put your points into a table, and then if you can't tell for sure if they're linear or not, remember that you can use this equation that we used earlier in the year. You can type y sub 1 and then a tilde, m x sub 1 plus b, and that will give you the line of best fit, or our residual line. And I can see pretty clearly that our line goes through all 3 points, so I know it's linear. So you could screenshot this and paste it right here, this is where your picture could go, showing your line going through the points. Doot, 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 right? So you can put your picture there.